Welcome to Compound Insights, a podcast by CFA Society New York. I'm your host, Rob Rowan. Today we're talking with Francesco Fabozzi. He is the research director at Yale School of Management's International Center for Finance. He also serves as the managing editor of the Journal of Financial Data Science, and he is the director of data science at CFA Institute's Research Foundation. So you can really read him a lot on CFA Institute's website. His research includes work on large language models and equity forecasting and some machine learning applied to quant investing. So today we're going to talk about a little bit of mix of all those three. So welcome to the podcast, Francesco.
Thank you very much for having me, Rob. Appreciate it.
So the reason we're here is to talk about Finbert. And so, it's a very interesting sentiment model. I'll kind of leave it there. Could you tell us a little bit about how it started, what you're using it for now, et cetera?
Yeah. So I think the purpose of the paper, Cut the Chit Chat, that I discussed the other week at the conference was we have a Finbert model that could do a lot of very sophisticated sentiment analysis previously. But as we've moved on to these generative language models, these are typically chat-based models.
Right.
So the issue that you have there is that when you try to formulate portfolios with these discrete label outputs from a chat model, you typically only have positive, neutral, or negative.
Right.
So you don't have this granularity of sentiment.
Right.
Whereas previously with the Finbert model, it was this multi-class classification model over positive, neutral, and negative sentiment, where you could obtain the probabilities that the model Finbert assigned to each of those.
Right.
So a lot of the literature was using these Finbert models. But now, as we move to more sophisticated models, we have to find a way of extracting those probabilities from these generative language models, like a ChatGPT or open source versions of them.
Uh-huh.
So a lot of what I had explained the other week was how we actually do that with a technique called logit extraction, which was, the purpose of this paper.
Yeah. So just parenthetically, I'd like to say that if you're a member of CFA Society New York, you can go back and into our website, log in with your CFA Institute credentials, and you can watch Francesco's presentation and also see the slides he used. And just if you're home or at your office, want to do it now, because some of this is a little bit complicated. So, but please continue about the logit issues that you raised.
Yeah. So the main issue again is that. So before we had these BERT models, which were ways of understanding text and converting it into numerical vectors.
Right.
So you would take a piece of text and you would obtain a vector out of it, which basically understands what's going on there so that you can train it to do some downstream classification tests. So you get this vector and it's supposed to really understand what is going on in the text. You could use this now as input features to another model. So you could think of it as a row on an Excel file,
right?
And you could then take that row and even use a linear regression to try to predict, or a logistic regression to try to predict positive, neutral, negative. Then you actually have the probabilities associated with it. So we want to have that same sort of setup for generative language models. And the difference is that generative language models predict text sequences.
Right.
So they're continually predicting the next word.
Right.
And what we do with logit extraction is we prompt the model. Instead of having to train it like we would with Finbert, we can prompt the model because it already has an understanding of what sentiment is, positive, neutral, negative. And we prompt it to spit its sentiment token out as the next word.
Right.
And that's typically where the literature has stopped. They take it and they just use positive, neutral, negative, which would correspond to 1, 0, negative 1.
Right.
Where you wouldn't be able to tell what the highest sentiment stock is and the lowest sentiment stock. If you have a cross section of, let's say, 100 stocks, how do you determine which ones you should buy, which ones you should sell? So now with logit extraction, before that positive, neutral, or negative is spit out, we actually go underneath the hood of the model, and look at the probabilities that the model's assigning to positive, neutral, and negative. And now that we have those probabilities, we could actually determine, oh, this is the most positive stock, this is the least positive stock, or this is the most negative stock. So now you could have this fine-grained variable that you can really discern the ordinality of the stocks in the cross-section relative to their sentiment.
Okay, so let me just play this back to you and see if I can put it into more layman's terms for the people whose ChatGPT usage has been limited to where they're going to eat dinner in Paris. The logit extraction addresses two issues. One of them was basically adjectives, right? So in the whatever text you're looking at, there would be words like protracted or very or et cetera that sometimes would smoke some of the previous birds. And then the other thing that it does is it allows you to address the much larger amount of granularity in the probabilities of those different sentiment ratings. Is that fair?
So I think that the second part is correct. You could achieve this granularity, but the first part is this would be comparing it to this Finbert model, which was already a sophisticated model. So I think what you were more alluding to was previous iterations of natural language processing, where you would have things like negation, where you would use a bag of words model, and you'd count the number of positive words relative to negative words, and that would confuse the model if you had, this is not very good, and then it would see very good, and it would say, oh, this is only very positive
because
text.
There's only one negative word, which comes out as the negative number, so they thought,
So that was sort of the beginning stages of natural language processing in finance, and Loughran and McDonald actually created this word dictionary that there were general word dictionaries before. Loughran and McDonald changed that because they were like, when you look at it in finance, these aren't actually, they were saying like, I think 3/4 of the words weren't actually negative if you look at them in a financial context. So that was a previous iteration. And now BERT model, actually, by creating this very long, dense vector of that understands the text, it actually understands these negations. And so the BERT model actually was already pretty sophisticated, and it actually does better in classifying sentiment compared to human annotators relative to some of these other language models that are trained more generically. But the issue now is it has to be trained specifically for a task. Whereas these other language models may have another understanding that helps them understand how this piece of text is going to relate to returns, subsequent returns. So they're more sophisticated models, but what I actually show in this paper is I say, listen, they can both do sentiment pretty well. It's not that one is much better than the other. ChatGPT 4 isn't much better at determining financial sentiment than a Finbert. But the characteristics of the output being that they aren't showing the underlying probabilities made it difficult for portfolio construction. So given that they're both good, and one is much easier to run, Finbert is much lighter weight compared to, you need institutional compute to run a lot of these generative language models. So really I went in and checked, okay, does it make sense? And it doesn't make sense to use these more computationally expensive models if you're only going to use positive, neutral, negative without the probabilities. So I show Finbert could do better than most of these generative language models if we're using it in that way. But if we use logit extraction and we actually extract these probabilities, then we could see a boost in all the risk-adjusted returns for all models. And then it makes sense to use the more sophisticated models. Relative to Finbert.
Yeah, so this is one of the things I was thinking about, because I played with Finbert a little bit, and to those of you who are listening, I'm not like a Python whiz by any means, but I found it only mildly complicated to set up. I was able to get it working with just a little bit of tweak to the Python code that rolled out of ChatGPT. I had to tweak it a little bit. Also, if you're an Apple user out there, just watch out. You got to have Python 3 installed. That was one thing that tripped me up. If you're Windows, you're fine. I guess this is one of the things I was thinking about as I was playing with it is, have we really gotten to the point where this seems obvious where it can have an impact on the return of portfolios, but can it help with portfolio managers' efforts to lower the variance of the portfolio or the risk?
Well, I mean, you could, let's say, with these more granular variables, you could determine, typically you would buy stocks, at least in the academic literature, you buy stocks above a certain threshold and value based on the sentiment, and short stocks below a certain threshold value. And with the way that the models were being applied before with positive, neutral, negative, you're really subject to the proportion of positive news in the cross section versus negative news.
Right.
So now you have, if there's a lot of positive news, the constituents of your positive or of your long portfolio are going to be much larger than your short portfolio.
Right.
So you're going to end up with most of the volatility in your portfolio coming from that short portfolio because there's fewer constituents.
Right.
So you're not benefiting from the diversification in terms of the number of assets. With probabilities, you can sort of choose your threshold, right? If you want less volatility, you could choose a higher quantile threshold for buying and selling and making those determinations. If you want higher volatility, more conviction in your bets, you can actually just buy more. But in terms of looking at it outside of sort of the quantile thresholding, it could be used as a risk management tool to alert people. But what I focus on mainly is sort of its implementation in a systematic framework.
Right. I was thinking about it in sort of broader terms across investment management. Because it does have some interesting things. You could handle it for risk management. Even compliance could use it on some level. So there are lots of different things. So that kind of leads me to what's next for Finbert, or whatever it'll be called after this.
So I think Finbert it's gonna be useful, and I think most of what I argue is how we implement these new generative language models. So we have to understand that Finbert is an encoder only model, which it provides a vector representation of the text, and generative language models are decoder only models. So they predict text sequences. So this gives them flexibility in how they can be used, because we can, instead of having to train, like a Finbert is a narrow model. It's very narrow and you have to have labeled training data in order to get it to perform different tasks. But these generative language models, there's much more flexibility, as we all can see when we use a ChatGPT. So I think what we have to understand is that when we use generative language models, they can actually be used in many ways, in a multitude of ways. So, for example, you could have an alert, right? If you're worried about some sort of risk monitoring or a specific risk for a specific company, you could just tell it, "Hey, I'm gonna feed news to you. Tell me if this is the alert. This is the event that I'm looking for."
Oh, cool. Okay.
Whereas a Finbert, it can only do positive, neutral, negative. So you would only be able to say, if there's really negative news about this company, just let me know.
Right.
But you could, with a ChatGPT, say, this is a specific event that I want. This is, and have more flexibility in those, in that way.
Okay. That's exceptionally cool, because investment management companies, all types of people, spend an awful lot of time thinking about what could go wrong.
Yeah.
And wasn't my favorite part of working in the industry at all. But it doesn't make you sleep well, but it is exceptionally effective. To have a tool like that would be great.
Yeah. I think actually a lot of, even like in the crypto markets now, a lot of people are using these generative language models in order to, it's pretty event based,
Right.
So,
Right.
a lot of people are using that, using these generative language models. So they have the flexibility of saying, okay, if you see Elon Musk tweet about something,
Right.
let's go figure out what the token or whatever the security is that you want to buy.
Yeah, right. You could think about this on a scale of event risk, right?
Mhm.
Or event, options. And it's
Yeah.
clearly, crypto's at one end of that spectrum.
Yeah.
But there are a couple other things around. There's a lot of synthetic assets that
Mhm.
have those types of things that are in everything from bonds to stock indices.
Yeah.
So,
Yeah.
there's
Definitely.
a lot of things like that happen.
Yeah.
Well, great. Well, perhaps we'll leave it there. We talked about a lot of different things. I just do want to
Mhm.
remind everybody, you can go to CFA New York's website if you're a member, and you can hear the whole hour that Francesco gave to the audience on this if you want to learn a little bit more. I really would encourage everybody. Just sit down in front of your computer for 20 minutes. You'll get it set up Finbert. First thing to do, go to ChatGPT, ask it nicely for Finbert coding. You basically put it into any Python IDE, get it to crank it out as an application, or I think you could probably run it in some terminals.
Google
And
Colab.
yeah, you can
That's a
collab
good-
it.
yeah.
Yeah. And then it downloads it for you. You just hit run and it downloads it for you. And you'll blink for a second because you'll think, well, that took a little while. And then it's like, all here. It's really easy.
Yeah. And that's actually what a lot of so the way that you were, because after I gave the talk, I had actually, you were going over with me how you go through this model. So it comes from Hugging Face. Hugging Face is like the GitHub. If anyone's familiar with GitHub, it's the GitHub of language models. All of these open source language models like Llama and Mistral, they're all available on Hugging Face. And the same framework. So Finbert is a bit simpler of a model to run, which is good to get you started. But a lot of the running these other models comes from a similar framework. So learning how to do Finbert can actually set you up to increase the complexity to some of these generative language models. You just have to figure out the compute, which is why Google Colab is a good tool.
Yeah. And also I had to figure out that Hugging Face was not actually a hacker profile.
Yeah.
It looked a little suspicious to me, but Hugging Face is actually the source you want.
Yes.
So thank you for that. And thank you for being here, Francesco.
Yeah. Thank you for having me.
So if you're interested in hearing more about how AI is impacting sustainable markets, including in due diligence and reporting, check out CFA Society New York's Sustainable Investing Symposium on January 29th. You can sign up here for it today. Until next time, I'm Rob Rowan, and this has been Compound Insights.